so the last class we discussed electromagnetism, electric charges, and etc. I know we talked about Coulomb's law. We said when it comes to electrostatics that there are two laws of electrostatics. The first one is that like charges repel and unlike charges attract. And we said the second law is also called Coulomb's law. And we said Coulomb's law states that the force of attraction between two charges is directly proportional to the product of the charges and inversely proportional to the square of their distance apart. And we said if I have two charges, let me call this Q1 charge 1, Q2 charge 2, and the distance between them, let me call this R. We have this. We said from Coulomb's law, the force of attraction between these charges is directly proportional to the product of these charges. So it becomes Q1, Q2, that's the first statement. And we said this same force is inversely proportional to the square of their distance apart. Here, their distance apart is R, so it becomes R squared. So we have this as the second idea. If I combine these two, we can see that F is directly proportional to Q1, Q2. At the same time, F is still inversely proportional to R squared. We had this. So if you combine this, I will have that F is Q1, Q2 all over R squared. Of course, this here goes to the numerator all over R squared. So we said we have a proportionality sign in mathematics. Take this man off and introduce a constant such that F now becomes equal to your constant here becomes K Q1 Q2 all over R squared. You have this. And we said this K is a constant which can also be expressed in terms of 1 over 4 pi E naught. We said E naught is called the permittivity of free space. And of course, this has a value of 9.0 or simply 9 times 10 to the power 9. Your unit here is Newton meter square per Coulomb square. So we have this. If you bring up this idea into this equation, you have that F is equal to K is this. So it becomes K dot Q1 Q2 all over R square. This and this are the same thing. So if I now introduce this concept here, it becomes K, we said is 1 all over 4 pi E naught. So it becomes this multiplying Q1 Q2 all over R squared. So F is now equal to 1 times this is itself Q1 Q2 all over this times this gives you 4 pi E naught R squared. So whether this one or this one, they mean the same thing. Right? They mean the same thing. E naught, we said is called permittivity of free space. So we discussed this one here in our last class. Most important, we said we can also express this man here in vector form. We said in vector form, we said this equation becomes this, that F is equal to what you have here, K constant, Q1, Q2 all over. This becomes the magnitude of R12. This one here, all squared multiplying this R12. So this is called the vectorial form of Coulomb's law. Alright? Here means what's called unit vector of the distance between charge 1 and 2. This one here is the square of the magnitude of the position vector between charge 1 and 2. And here's your force. So we discussed these ones in our last class. So let's take different cases and look at how we solve problem on this. We look at a linear charge configuration, we look at triangular charge configuration, we look at square charge configuration, also look at rectangular charge configuration. And of course, also look at semicircular charge configuration. Alright, let's do linear charge configuration. Let's do linear charge configuration under Coulomb's law. Linear charge configuration refers to charges being arranged on a straight line, either vertically or horizontally. For today's class, look at a horizontal charge distribution for today's class. Take that please. Sample problem 1. Two charges, 15 microcoulomb and minus 21 microcoulomb are 85 cm apart. Are 85 cm apart. If a third charge at 65 microcoulomb, if a third charge 65 microcoulomb is placed midway between both charges, find the resultant force on the 15 microcoulomb charge. Find the resultant force on the 15 microcoulomb charge. Alright, so look at this. So here's how it works. Look at this. Here's how it works, please. I would advise that the first thing is for you to plot a diagram. So from here, this one here, and this one here, we said two charges there. The first one was what? What was the first one? Sorry? Okay. I have this as 15 microcoulomb. And what else again, please? Minus 21 microcoulomb. Alright, so we have these two here. How many cm apart, please? 85 cm. So from here to here is about 85 cm apart. So we have these two. Alright. Next statement says a charge, a third charge. What's the value of the third charge? Is placed where? Midway. So midway, somewhere around here. A third charge. How many gave these? 65. That's a microcoulomb? Yes. 65 microcoulomb is placed midway between these two. So question, if from here to here is 85, what will be midway? That becomes 85 divided by 2. So what do you get? 42.5. That means this is midway. From here to here is about 42.5 cm. From here to here becomes another 42.5 cm. So we have this as the third charge being placed midway. Please, it's not always midway. They can say the third charge is placed 20 cm from the 15 microcoulomb charge. If the sixth man is placed 20 cm from the 15 microcoulomb charge, that means this one here would come somewhere here, such that distance between this and this would there 20 cm. If they say the third charge is placed at 30 cm from the minus 21 microcoulomb charge, I'll bring this one somewhere here, such that from here to here becomes what there 30 cm. So this one here must not always be at the center. Mind the language being asked. That's the first task. Next up, of course, obviously, I'll have to do some conversions. Right? I have microcoulombs converted to coulombs. Micro is times, think about what there? Minus 6. Next up, I'm given distances in terms of centimeters. I must convert. So please help me please. Convert this to meters, divide by 100. What do you get? So convert 42.5 to meters becomes 0.425 in meters. That's this. This one also from here to here gives you 0.425 in meters. So I have these two as my conversion to meters. Right. We have to find the resultant force on this one here. Your next task will be label each of them. Label the charges, either as Q1 or Q2 or Q3. So my task will now be let Q1 be equal to this one here, 15 microcoulomb. Q2 be equal to this one here, 65 microcoulomb, and then Q3 be equal to this one here, minus 21 microcoulomb. So I have this one here. So I have Q1, Q2, Q3, please. Define them, please. Define them. I'm done defining them. Please. We are asked to find the resultant force on the 15 microcoulomb charge. 15 we said is Q1. So let's find Q1 resultant. Here. Let's find Q1 resultant. The resultant force on Q1, your formula is this. F1 resultant is equal to, of course, becomes the force of, this time should be a repulsion because they have the same sign. It's positive, positive. So it becomes a portion. But whichever way please, becomes the force between this and this. That is F12. Between charge 1 and charge 2, that's these two, and of course, plus the force that exists between this and this. So it becomes F13. Right. The resultant force, also called net force, is the force between this charge and this charge, and this charge and this charge. Combine them, you have your resultant. To get the resultant, first of all, I need this one. After getting this now, add the value to this one. So task 1, let's get F12. From here, F12 is equal to, from Coulomb's law, F12 in vectorial form becomes K Q1 Q2 all over R12, this one here, all squared multiplying or dots the unit vector of R12. So we have this. Your first task, look at this. After writing formula, your first task is always to find this one here. Let's get R12. What's R12? R12 is simply the distance from charge 1 to charge 2. The formula is given by R1 minus this one here, R2. So I have this. To analyze this properly, you need to go back to your Cartesian coordinates. In Cartesian coordinate system, I have perhaps. Right. In Cartesian coordinate system, I have this. Where this one here is the position of positive x. This one here is negative x. This one here is your negative y-axis. This one here is positive y-axis. So here's the case. If I'm moving towards the right, please take note. If I'm moving towards the right, I'm moving this way. That is your positive x direction. So it becomes positive. If I'm moving towards the left, that's this way here. That's the direction of the negative x. So it becomes negative. Please, this is very crucial in doing this. So case 1, I'm having R1. You take this as your origin. For the origin, the distance there is 0. So this now becomes 0 minus. So the R1 becomes your origin. So here's now my origin, which is this point here. This becomes my origin. This is R1. Of course, where Q1 is. Q1 is this. So here becomes Q1. Next up, minus. R2 is the distance of charge 2. This is charge 2, 65. Where is 65 on this diagram? 65 is at this point. If here's my origin, I want to move to 65. From here, I'm coming this way, please. Am I moving to the right or to the left? I'm moving to the right. So from my Cartesian coordinates, if I'm going to the right, should it be positive or negative? It becomes positive. So here now becomes positive. Distance from here to here is what there? 0.425 becomes 0.425. Next up, one more thing you must add here is the concept of I and J. If I'm moving in the X direction, you add up I. If I'm moving the Y, it becomes what there? J. One thing you should notice is people write I and J almost like the same thing. So in vector form, when you're doing I and J, observe that I called mine. Because some people say I is this, J is this. This is I and I to some persons. So just to avoid the confusion of which of them is I, which of them is J, you curve it. So for I, intentionally curve it to the right. For J, curve it to the left to avoid that confusion. So this now becomes this man here, I. What does I mean? I'm walking on my X direction. So it becomes I. Next up, this man is in meters. So you can say this man meters I perhaps. I have I. So I have this piece. Any questions so far? Origin is 0. I'm coming here. Becomes positive. Distance is this. Meters is on the X axis. So it becomes I. Any questions so far? None. From here, I'll have that arrow 1, 2 is equal to 0 is up. Minus plus is minus, it becomes minus 0.425 meters high. 0.425 meters high. Your first task, again I repeat, is to always find this one. Always. If I'm not getting this, what's next? Next up is to look for the magnitude. The magnitude becomes this. This is magnitude, alright, this one represents magnitude. So in magnitude, what do? Simply take square root of that figure and square it, okay? Square root of that term and square it. So it becomes the square root of this value in brackets minus 0.425 all square, please. Square root of this term all square. That's how we take magnitude. Alright, next up please, look up, next up. Here's what to note. If I have something of this nature, let's say minus 3 all square. Observe that the square is affecting both minus and 3. So minus 3 all square will be minus 3 times minus 3. And that will be equal to minus times minus is plus, 3 times 3 is 9. What does this mean? If I'm doing all square of a negative term, it will give me positive. Please take note of this one. People usually make this mistake. After square, they still have negative. It's not possible to give a positive term. Alright. So this will now be equal to, I will have that R1, 2 will now be equal to the square root of, please square is what you have? 0.180625. Please take square root, what do you have? 0.425. That gives you 0.425. So look up. Look up it. Look up it. Let's see. I'll say this once and I'll be skipping it from here. Here's what you should notice. Whenever we get to this point here, two things happen. Number one, this square will cancel square root. Number two, minus will disappear. Don't forget. The square will cancel square root. Now, for the fact that this one here is cancelling the square root does not mean minus will stay. No. The minus will also what they do there disappear. Please don't forget this, please. So from here now, moving here straight. Alright? This mark goes up, this cancels it. So I have this value. Number one. If you're done with this then, what next? Next up, we'll find this. This is called the unit vector of 1 and 2. We call this unit vector. What's a unit vector? A unit vector, as we said in vector class last semester, is a vector whose magnitude is what? 1, right? A vector whose magnitude is 1 is called a unit vector. How do we get unit vector? Unit vector is equal to the ratio of the position vector between 1 and 2 all over the magnitude of arrow 1, 2. So you have this. Please. Ratio of unit vector, unit vector becomes ratio of position vector to magnitude. And that's equal to, first of all, get position vector. Arrow 1, 2, which is this. We got this as, this should have a unit place. Have a unit place. Right. Should have a unit place. Sorry. Alright. Let's focus on our place. Alright, so this now becomes, this value gives you minus 0.425 meters high. That's for this one here. All over this one, magnitude gives you 0.425, of course, meters. So we have this one here. Please add the meters. The idea is that the meters will cancel out. This is important. Meters cancel out. From here, this can cancel this, it's off. Meters can cancel meters, it's off. So I'll have that arrow 1, 2 is equal to minus. Alright. So it now becomes, of course, this one is off, meters is off, and left with minus r. So this becomes minus r. So I have this. So my unit vector is minus r. If I compare this now with this, I've gotten all my values. This is 9 times 10 to the power 9. Q1 is here already. Q2 is here. This value, magnitude of this position vector, is already given here as this. This is squared, no problem. I've gotten unit vector as this. So I can now simply substitute and solve. Copy this please, are we done? Let's recall what we said. We said that F12 is equal to K, Q1, Q2 all over R12 all squared dot unit vector of R12. So from here, it means that F12 is equal to K. K we said is 9 times 10 to the power 9 into Q1. We said this is Q1, 15. Due to the micro, it becomes times 10 to the power minus 6 into Q2. This is Q2. Due to micro, becomes 65 times 10 to the power minus 6. That's for this. All over, we said magnitude of R12. Please check. This value was what there? 0.425 all what there? Square dot. This gives us what there? Minus r. So we had this as minus r. Alright. So we had this value, please. Help me out, please. From here, I will have that F12 is equal to, please point only numerator. What do you have? Just numerator. What do you have? Just numerator. What do you have? So I have 8.775 all over. Please square denominator. What do you have? Sorry? 0.180625 all into what there? Minus r. Please do this division. What do you get? Divide this, what do you get? 48.58 into what there? Minus r. So if I multiply this, I have this as what there? 48.58. Of course, I'm measuring first, and first is measured in terms of Newton. So it becomes Newton. Hold on. This minus comes here, becomes minus 48.58 Newton r. So this becomes F12 minus 48.58 Newton r. Look at this. We have to find F1 resultant. For F1 resultant, we need F12 and F13. I've gotten F12 as this value. My next task, get F13. Alright, so let's get F13 please. Alright, so let's now get F13. We said from Coulomb's law in vector form, F13 becomes K, Q1, Q3 all over R13, this one here, all squared, multiplying unit vector of R13. Alright, what we said R13 is equal to R1 minus R3. Alright, and we said R1 becomes your origin. So it becomes 0 minus, let's get R3. Now R3 is the distance of charge 3, that's here. My R1 is here, my origin. If I want to move from R1, of course, if you want, put it in brackets. If I want to move from R1 to R3, I'm going towards the right. And from Cartesian coordinates, right here is the positive of x. So going this way now becomes positive because that's your positive x direction. So I'm having a positive. Next up, distance from here to here becomes from here to here 0.425 plus from here to here 0.425. So combine these two, what do you get there? 0.85 meters. Is it I or J? I. So it becomes I because it's the x direction. So work this man up is equal to zeros of minus plus is minus 0.85 meters high. So I have this. So this becomes R13 as minus 0.85 meters high. Next up, we said get the magnitude of R13. For magnitude, we said take square root of this man here minus 0.85 all square. Alright. So take square root for this. This will now be equal to, we've discussed this before. We said this cancels this, minus also disappears. So it gives you 0.85 meters. That is the magnitude of R13. I have this value. Alright, what next? Get unit vector. The unit vector of R13 is equal to the position vector of R13 all over the magnitude of R13. And then this will now be equal to, so R13 correct will now be equal to, this value is what we have here as minus 0.85 meters high all over, this value is what we have here as 0.85 meters. Obviously, this will cancel this, meter will cancel this, so it's equal to minus I. So I have that the position vector, the unit vector of charge 1 and 3 is equal to minus I. Take note, unit vector between 1 and 2 was minus I. 1 and 3 is minus I. It doesn't mean it's always minus I. You can also have I and J in some rare cases. Till we get there. So we have this. Let's substitute into this one here, into this equation. What do you get? So therefore F13 is equal to set K is 9 times 10 to the power 9 into Q1 is this 15 times 10 to the power minus 6 into Q3 is this minus 21 times 10 to the power minus 6 due to the micro, this one here, all over R13, that was what there? 0.85 85 squared times unit vector of R13. Check. We had this as what there? Minus R. Please give me just numerator. What do you have? Minus 2.86 minus 2.835. 835, is that all? Alright. All over, this one gives you what? 0.72725. Alright. Dot minus R. Of course, that's equal to, punch this, what do you get? Minus 3.924 Newton is a force multiplying minus R. So that's now equal to minus times minus gives you plus. That now gives you 3.924 Newton R. This now becomes the value of F13. So I have this. That becomes the value of F13. Minus minus gives you plus. So I have this as F13. We have to find F1 resultant. Let's get F1 resultant. Let's get F1 resultant. Alright, so therefore we are asked to find F1 resultant. So therefore F1 resultant we said is equal to F12 plus F13. Please give me this value again, please. Minus 48.58 Newton I plus, so it gives you 3.924 Newton I. Next up, take off the bracket. So it becomes, take off this bracket. I'm having minus 48.58 Newton I plus 3.924 Newton I. And that will now be equal to minus 44.656 Newton I. So this becomes the value of F1 resultant. Alright, so we have this as F1 resultant. In some questions, you'll be asked to find the net force or the resultant force on each of them due to the order. That means you have to find F1 resultant, F2 resultant, and F3 resultant. That means what we've done so far is just 1/3 of the answer. So in case like that, what do? I'll give you a shortcut for that. But before the shortcut, let me show you something. Alright. Let's say we have to find F2 resultant, for instance. Alright. Let's get F2 resultant. F2 resultant will be equal to what? What will be your formula there? F21 plus F23. Let's get this one here. Let's get F21. What's F21? From Coulomb's law, F21 is equal to that will give you what there? K, you can say KQ2 Q1. But use the idea of what's it called? Something called commutative property of numbers in maths. From commutative property, it works for addition and multiplication. It states that irrespective of the position of arrangement of numbers, so far as they are adding or multiplying, you have the same answer. It's called commutative property. For instance, let's say I have 3 and 2. Let me add them. Becomes 3 plus 2. That gives you 5. Reverse the order. Becomes 2 plus 3. It still gives you 5. It's called commutative property of numbers in maths. Also works for multiplication. Multiply them. I'm having 3 times 2. That gives you 6. Reverse the order. Becomes 2 times 3. I still have 6. This stuff does not work for subtraction, does not work for division. If you subtract them, 3 minus 2 gives you 1. 2 minus 3 gives you what there? Minus 1, not the same. If you divide them, 3 over 2 gives you what there? 1.5. 2 over 3 gives you what there? 0.66666666. It doesn't work for. So that means for this one here, this becomes KQ, you can say KQ2, Q1, or better still, KQ1, Q2 is the same thing. Commutative law, they are multiplying. You have the same thing. All over, arrow, please, in this one, do not reverse it. It must be arrow 2-1, not arrow 1-2. Because you're dealing with vectors. And vectors go with direction. So you must be 2-1. Don't reverse. You can reverse this one, but don't reverse this. So this one here must be 2-1 here. All square dot unit vector of arrow 2-1. Very please don't reverse this one. Say it again. Alright. First things first, focus comes to this. Let's get arrow 2-1. Arrow 2-1 we said is equal to R2 minus R1. Now we said this one is always your origin. R2 becomes 0 minus R1. Now look up. In this case, R2 becomes your origin, which is here. This is R2. That's distance of charge 2. Here becomes origin. Back to Cartesian coordinates, I'm having this. We said here is positive x, here is negative x. This is 2. They said 2, 1. Next up, locate the position of charge 1, which is here. So if 2 is my ordinal, I'm going to charge 1. That means, am I going to the left or the right? Yes. I'm going to the left. Please, from the Cartesian coordinate, if I go to the left, should it be negative or positive? Negative. So observe becomes minus into negative. Distance from 2 to 1, what's the distance there? 0.425 meters. I or J? Becomes R. Please notice this change. Becomes R. Please notice this change. I'm moving. So look at your direction and tell. Any question here? What do you get it? Right. Minus gives you plus. Huh? Minus gives you plus, it becomes 0.425 meters high. This is R21. This is R21. I have this value. Next up, get magnitude. Magnitude of R21 will be equal to, we said, the square root of this man here in bracket, 0.425 all squared, where this will cancel this, and that will give you 0.425 meters. This becomes the value of the magnitude of 2 and 1. One final task, position vector. One final task, unit vector. Yes, unit vector. Alright, unit vector of R21 is equal to the position vector of R21 all over the magnitude of R21. So play with this value, we had it as here, 0.425 meters high, all over this value, we had it as this, 0.425 meters. So the number cancels the number, unit cancels unit, and left with I. That means the unit vector of R21 is equal to I. That's I, positive I. So I have this. Alright, substitute all of this back into this formula. Substitute all of this back into this formula. Let's see what we get. Right there. Let's substitute values, please. Let's substitute value, please. Alright, so put back all of those values into this equation. I'm having K as 9 times 10 to the power 9 into Q1, which is this, 15 micro times 10 to the power minus 6 into Q2, this one here, 65 times 10 to the power minus 6 due to the micro all over. This one becomes 0.425 all squared. Check this value was this all squared dot. This one becomes I. Please punch all of this. Punch all of this. Like punch everything together. What do you have? What was the value? Everything here together. This is similar to 1, 2 now. Check. So you have what there? 48.58 what there? Newton into what there? I. So this now gives you what there? 48.58 Newton I. This becomes the value of what there? F21. What do you notice? Now listen up. Notice that check F12. F12 was this value, but it was negative. So here's the inference. Look at this. Here's the inference. Get these inferences. Look up. Get these inferences. Notice that F21 is equal to minus F12. Check. Is minus that value. Notice that from here, okay, let's say 31 will be equal to what there? Minus F13. So here's the idea. Look at this. Here's the idea I'm trying to pass. Look up. I'm going to pass this idea. See this, please. See this. If I'm to get F1 resultant, F1 resultant is equal to F1 F2 plus F1 3. Notice that F2 resultant is equal to F21 plus F23. In the same vein, F3 resultant is equal to F31 plus F32. Now, here's what to observe. If I find the value of F1, automatically I've got the value of what there? F2. If I get the value of F12, automatically I've got the value of what there? F21. Just attach minus. If I get the value of F13, automatically I've got what there? Value of what? F31. Just put minus. If I get the value of F23, automatically you now also get what there? The value of what? F32. Just put minus. That means in this one here, I need 6 values. 1, 2, 3, 4, 5, 6. But in recess, I need only 3. For every one you get an extra one. Just add a minus. For every one you get an extra one. Just add a minus. For every one you get an extra one. Just add a minus. That's how this might work. So if they say find the net charge on each of them due to the order, they don't expect to start doing all of them. No. They expect that you should know just 3. Know this one here. When you know this, you get this one. Just put minus. Know this one here. When you get this one, you get this one automatically. That means I'll just focus on getting only 3. That's F12. Knowing that I've also gotten this one too. Next up, F13. Knowing that this will be minus of this. And finally, F23. So you don't start coming to say F12. No. Go straight to F23 because F23 becomes what there? Minus this one here. So are we good? Alright, so that's how you work on this problem. So what this means is that if I was asked to find the net force on each charge due to the order, I only have to find the value of 3, which is F12, F13, and F23. Because I know I can get F2 from F1. Since I know that F21 is equal to negative F12. So on getting this, I also get this one automatically. Also, I can get F31 from this one. I know that F31 is equal to negative F13. So I've gotten 1, 2, 3, 4. Finally, get this one. I'll also get the value of this, knowing fully well that F32 is equal to negative F23. So we have this. So if only I can find this value, and this value, I'll just need to attach minus to each of them to get the other value. Then substitute here and sum them together to get each of them. That's how you solve this question. Alright.